Hey everybody, so we're going to be going over the notes for section 1.2, which is linear measure, but we're actually really focusing on the segment addition postulate, okay? And we're going to get right to it. So the definition itself is going to be if we are given 2 points on a line segment, and we're going to call that line segment, let's say those 2 points are A and C. A third point, which we'll call B, lies on the same line segment. And we're going to say that line segment is AC. That indicates that the endpoints are AC. If and only if the distances between the points meet the requirements of the following equation, okay? And that equation is this: AB plus BC equals AC. Now you'll notice I don't have a line segment symbol above this. So this is not line segment AB plus line segment BC equals line segment C. This is actually distance. This means the distance between A and B plus the distance between B and C is equal to the distance between A and C. And we're going to show that graphically over here. So we're going to draw a line segment, okay? We're going to say, remember the endpoints are A and C. So that means this is going to be A, this is going to be C. And B is on that line segment if this distance plus this distance is equal to that distance. So AB plus BC equals AC. That's a graphical representation of the segment addition postulate. This is a really long-winded way of saying that these two little segments make up the big segment. Okay, that's the whole message there, basically. Okay. Now I'm going to go through these examples with you. All right. I'm not going to do all of these, but I'll do like one or two, and you can finish the rest on your own. And you can check with me and see how you did. Some of you guys will be doing these in class. Some of you will be doing this at home. So if you have questions, feel free to message me on Google Classroom or shoot me an email or whatever. Okay. So here we go. Let's look at number one here. We got a ruler here. It's asking us to find the length of each line segment or object. I'm going to zoom here so you can see a little better. Okay, there we go. So we know from here to here is the segment. We're going to find out how far this is. Okay, we know this is 1. And from here to here, we don't know how far this is, but we do know they've divided this up. So here's what I'm going to do. I'm going to count these little tick marks here. So 1, 2, 3, 4, 5, 6, 7, 8. That's the halfway point. So the halfway point is 8. Obviously, the whole thing is 16. Okay? So 9, 10, 11. So this is actually 11 sixteenths, right? This would be 11 out of 16. So that's going to be our fraction. So 11 is our numerator, 16 is our denominator, and our number here is 1. So this is a mixed number. So this is the distance, but don't forget to write the unit of measurement, which in this case is inches. And that's it. That's all you got to do. So you're going to do something similar over here on your own, and you're going to do something very, very similar to what we just did. Okay? Let's go down here. Let's do one of these. Let's do, we'll do the first one. So find the measurement of each segment. Assume that each figure is not drawn to scale. So, okay, drawn to scale means it's not necessarily going to be, the length is, if it's longer, it's not necessarily going to look that way, in other words. So we'll do number 3 here. So find the length of PS. So PS is the entire line segment. So we know that PQ plus QS should equal PS. So we can just add PQ and QS together, and that should give us the length here, right? So 18, excuse me, 18 and 4/10 centimeters plus 4 and 7/10 centimeters should equal PS. Now, I like to actually draw it the old-fashioned way. I like to draw it vertically when I'm adding anything with place value like this. I find it easier. I know it seems kind of kiddie, but I like to do it that way. So 4 plus 7, 11, carry the 1, 12, 13, carry the 1. So we have 23 and 1/10. centimeters. Okay, so 23 and 1/10 centimeters. Okay, so that's how we did that one. Now these others are going to be a little different. This one's very similar to that one. This one's different though, so I'll let you guys figure those out on your own. Okay, and then in the back here, oh, that's not it. There it is. So we have two examples here. I'll do the first one. Oh, focus. There we go. So let's read the directions. We got find the value of. It's still a little blurry. Let's see if I can fix that for you. Hold on. Come on. It's a little better. Okay, so find the value of x and kl if k is between j and l. So we know k is between j and l. I'm going to draw this. I'm going to make a little. You know what it is? It's my pen because it's getting so close. Let's see if I can. Let's see if I can do this. All right, so we're going to draw a line segment. We know k and l are the endpoints, so k and l are here. And obviously this will not be drawn to scale, so because I have no way of knowing which piece should be longer, so obviously this is not drawn to scale. So j, yeah, j, I totally screwed that up, guys. Totally screwed it up. So it's between j and l. The endpoints are actually j and l. So j and l go here. K goes here. There we go. Okay, now we're looking for x and the value of kl. So jk is 6x, so 6x will be this length here. KL is 3x, and JL, the entire line segment, the large one, is 27. Okay. Okay, so we have to solve for x, and we have to solve for KL. So I'm going to write this out as a segment addition postulate. So I'm going to write JK, which is this little line segment here, plus KL, which is that little line segment there, is equal to the entire line segment, which is JL. All right, so these are the three values we need. So we're going to plug these in. So JK is 6x, KL is 3x, and JL is going to be 27. And then we're just going to solve this algebraically, right? So we're going to combine like terms. So 6x plus 3x is 9x. And we're going to get x by itself. So we're going to get rid of the coefficients. We're going to divide both sides by 9. And x will be equal to 3. And there's no units here, so don't have to worry about that. So we have x, but don't forget to solve for KL. KL is 3x. So 3x, we're going to plug in our x value, which is 3. So 3 and 9. So KL is equal to 9. And that's that. So that's how you solve this problem. This is very similar. I'd recommend drawing it out. And that should help you walk your way through it. Okay, so this should help you with the worksheets that I posted that are going to be due on Monday. If you have any questions, like I said, just contact me on Google Classroom or on email, and I'll help you out. All right, thanks, guys.